Hello, everyone. I'm grateful to have been offered the opportunity to provide a talk at the Enable Innovation at Speed event here in Pune. Uh, I'm also grateful that Naladri Chaudhuri, the organizer of this event and CEO of Zalantro Consulting Services, has invited me to provide this talk in particular. DevOps Test Engineer is a certification course offered by the DevOps Institute in partnership with reps such as Mr. Chaudhuri's organization here in Pune in India. The topic of the talk, of course, is DevOps test engineering. And after spending a few minutes of introducing myself, I'll get straight into the talk. Thank you. As I mentioned, my name is Marc Hornbeek. I have entitled myself DevOps the Gray on the internet, partly because I just have many years of experience with DevOps, and maybe it's the color of my hair too. But fundamentally, I really enjoy topics of DevOps, and in particular the testing aspects of DevOps, and I'll explain why shortly. If you want to contact me separately, I recommend you connect through LinkedIn. You can also look at some of my articles on DevOps.com. My day job, I am a principal consultant of DevOps for the total DevOps practice at Trace3. We serve enterprise clients with a wide spectrum of DevOps consulting services, and we have a large network of service and product partners to support our practice. In addition, I am a course author for the DevOps Institute. I'm the author of this course, DevOps Test Engineering, as well as the Continuous Delivery Architect course, and uh, I have certifications on DevOps from the DevOps Institute. In addition, I'm a blogger on DevOps.com. I write about a variety of DevOps related topics on that website and have done for some years. I am also an IEEE member for more than 40 years, was awarded the IEEE Region 6, which is Western United States Engineer of 2016, for my lifetime work in the area of automation related to testing and development in networks and labs, and in particular DevOps. In this talk, I will cover a number of topics, not strictly in order, but I will promise you I'll cover these topics. So first of all, I'll talk about what is test engineering and to some extent what it is not, or at least in comparison to traditional test methodologies. And I'll also be speaking about why is DevOps test engineering important in general and to DevOps in particular. In addition, I'll speak about test engineering strategies and best practices as they relate to DevOps, benefits of test engineering, as well as consequences of not getting test engineering done correctly. And finally, I'll provide some references to those that would like to explore further learning in this area of DevOps test engineering. By the way, the little symbol at the top is just one that I happen to like. You've probably seen the infinity sign used in association with DevOps a lot because of all the continuousnesses of processes related to DevOps, and just provide a little circle around it to emphasize the fact that hey, there's processes within processes that need to get done right in order to really accomplish DevOps properly. To some extent, testing is a subcomponent of getting DevOps right, but it also has components within itself as well that need to be done properly. So it's just a little symbol you'll see I use once in a while. I hope that's interesting to you. This slide is perhaps a dramatic way of representing a saying that I like to repeat. I think I'm the one that came up with it, but I believe in it strongly, so I do repeat it a lot. A lot of people talk about how culture is, a requirement to get DevOps right, which it certainly is. It's the door to DevOps, if you like. But once you open the door, culture is not enough. And really, at the heart of all of the mechanisms and processes that go behind making DevOps work, behind the scenes or under the hood, if you like, is continuous testing. So I say continuous testing is really the primary key to continuous delivery. So yes, culture is the door to DevOps, but continuous testing is the primary key to continuous delivery. in my opinion. And I'll explain more as in the remainder of this talk about why I say that. If you read the State of the DevOps report that's published every June, you'll find out that the results of doing DevOps right is almost magical, right? It's a magic ingredient that allows companies to at once accelerate their deliveries and at the same time, improve their lead times, improve quality, get better, job satisfaction for employees, improve security. So that's almost a magical thing if you get DevOps right. But, how do you do it? There's lots of enterprises that are struggling to do DevOps at all. And one thing I think a lot of folks don't really properly understand, one of the magical ingredients that enables DevOps is actually test engineering. So it's not just a matter of, automating tests. It's an engineering problem where testing is integrated throughout the DevOps continuous delivery pipeline. Why is that so important? Because every stage in the delivery pipeline requires some data to decide whether or not a change that's going through the pipeline is good enough to be progressed from one stage to the other or promoted. So testing provides verdict data that enables that assessment to decide whether artifacts that are going through from one stage to the other are good enough. It's the you know decision information that's needed to decide, is a change good enough or should it be promoted or in fact possibly reverted if there's a problem. The key to really understanding how to do this is really under the hood in the best practices of test engineering, and that's what this talk is all about. So how is DevOps testing different than traditional quality assurance testing? I will explain, what's kind of the old way and the new way. And continuous testing is really the same thing as test engineering, but engineering has the idea of integrating it into the process of pipeline and other engineering processes. So, at the heart of it is really a question of how mature are your testing practices. Frankly, if everyone used even waterfall, they were very, very mature about how they're doing testing, even in a waterfall environment. A lot of the same practices would apply as I'm talking about here, but they become critical in the context of DevOps environments where changes are happening very quickly. In particular, you cannot have a quick continuous integration or continuous delivery cycle if your testing is not mature enough to accomplish its coverage and results quickly. That requires careful engineering, and I'll explain how that is done. By the way, that little crazy figure at the right-hand side, that's actually me. I was just having some fun one day with the idea of DevOps the Gray, and my son took some pictures of me in a costume just for fun. So don't be alarmed by that. It's just for fun. And I hope you all have fun with DevOps test engineering also. This slide depicts one of my favorite myths that's associated with DevOps. I actually get kind of frustrated when I see people depicting testing in a DevOps pipeline as a stage or phase of testing. Usually they're talking about acceptance testing coming after integration and before delivery or deployment, but definitely testing in general is not a phase between integration and delivery. Testing scope is really end-to-end. Testing is occurring at every stage in a continuous delivery pipeline, and this talk is emphasizing that, and definitely from an engineering point of view, it's critical to consider that testing is an integral part of every step and every stage of the process. Ironically, testing is what really is continuous about continuous delivery pipelines, whereas integration and delivery and even deployment are not truly continuous because they're interrupted by testing. You can't just, have them continuously integrate and deploy without test results to validate that they're producing good artifacts. So it's an interesting conundrum from a, terminology point of view. But, keep in mind that when you see people depicting testing as just a phase in the pipeline, that's not strictly correct. And I'll explain more about that. This slide essentially is a definition of DevOps testing and test engineering and the differentiators between DevOps testing and other types of test methodologies. First of all, DevOps has to do with a continuous delivery pipeline or series of stages. Every organization has a different definition of what those stages are. I happen to like this one, but every company or organization has a different view. So I talk about design, where people are designing what a change will look like, and then creating it, which could be coding, and then integrating, which could be integrating the changes into a trunk build, and then building, and then binding it together into something that can be deliverable artifacts, and then delivery to produce something that can be delivered, whether you actually deploy it or not. And finally, deployment, where whatever has decided to be delivered is decided to be good enough, and it's time to push it out to production. So there's sort of three major phases there. A lot of people talk about CI as the middle environments, continuous integration, and then continuous delivery deployment. It's kind of ambiguous. CD is really often described as delivery and sometimes deployment and sometimes both, but it's CD phases. I also like to emphasize what happens prior to integration, and I generally refer to that as pre-flight from a testing point of view. Getting everything ready for integration as a set of activities that are called pre-flight. So DevOps testing is really significant end-to-end across all of these stages through design, creation, integration, build, binding, delivery, and deployment. So the scope of DevOps testing is actually broader than anything else that people refer to in terms of CI or CD. What are the key differentiators? Well, first of all, DevOps testing is a continuous quality assessment for each pipeline stage. Tests can be running literally continuously. There's the old adage, which is true, that testing is a statistical process, so there's never enough testing. But of course, you can't run every possible test, but you run as many as you can given the time that you have before you have something else to do. So in a proper environment, you're taking advantage of the time that's available and the resources you have to continuously run quality assessments with the resources that you have. Second of all, most tests are automated from the beginning. In many environments, it's not really possible or practical, and sometimes not even advisable to automate every single test. But there are some good examples of certainly most tests, in the best practice environments, it's usually something greater than, let's say, 80–85% of the tests are automated. And also the tests are integrated within all stages of the DevOps tool chain. So all the tools associated with making things happen across the pipeline that are stitched together to make an automation chain of tools. Testing is integrated at within every one of those tool chain environments. And finally, another differentiator with DevOps is that a production equivalent test environment is used within each stage. So you don't wait until the end to try out a change in a production-like environment. Even back at the pre-flight area, you try to have a good representation of what the deployment environment is going to look like and conduct tests prior to integration as much as possible. So these are key differentiators that DevOps testing really emphasizes and are important and emphasized more than in, let's say, waterfall or agile or even ITIL, test methodologies. This slide emphasizes the whole point of testing. I mean, frankly, testing is in it of itself does not add value. That's one of the reasons I describe the pipeline stages the way that I do. If you look at them, they basically indicate, value-added activities, and testing is not really explicitly mentioned in any of them. But what everybody really wants are test results, and if they could be accomplished without any cost or effort, that'd be great, right? But in reality, that's not reality. So you want them to be accomplished efficiently. And the real point of testing is to get information that you can use to assess the value-added components, whether the value-added component is a design or code or the integration of things or builds and artifacts and releases and so on. The point is that in continuous testing and continuous test engineering, every stage has an assessment conducted to determine whether or not the artifacts resulting from those value-added steps or stages are in fact good enough to be accepted into the next stage, or they need to be rejected and more work needs to be done before they're promoted to the next stage. This slide talks about what happens with artifacts that are rejected by testing. Many of the written documentation and articles around continuous delivery indicate that with continuous delivery mechanisms, you essentially keep promoting things and then stop the line like the andon cord in a lean manufacturing environment equivalent. You just stop it and then fix things. But in reality, you can't always, and it may not make sense to completely stop a continuous delivery pipeline just because tests are not, passing completely. So there has to be some level of decision making, and that's what the assessment is all about. So rejected changes are certainly analyzed immediately in best practices environments, and hopefully some of that analysis, as much as possible, is an automated analysis using built-in thresholds and so on. Let's say it's a microservice, and certain number of tests are deemed critical and others are not so critical. So an assessment would be, if the critical ones didn't pass, then you would stop the line and fix them immediately. But if some of the others are not, the lower priority ones don't pass, then maybe you'd carry on and you'd schedule remediation by throwing out a bug report or something, and they'd get fixed soon, but not necessarily stop the line. So serious changes halt the pipeline until the rejected change is either removed, or another terminology is rolled back to the prior version, or remedied or resolved. But less serious changes can be promoted to the next stage and scheduled for remediation later. That's the idea of the little decision box assessment. This slide deals with one of my favorite topics, which I think is not really treated enough in a lot of literature on DevOps and continuous delivery. The concept of what happens prior to a CI/CD, in particular, and prior to CI, there's development activities, and they need to be done right in order to, be worthy of integration. So there's different approaches, but everything leading up to the integration point in a trunk branch I call pre-flight testing. And pre-flight testing refers to assessing the design and software code prior to integration. Consequences are extreme if this is not done correctly. Errors integrated into the pipeline would have very negative ripple effects later in the DevOps pipeline stages, and essentially a lot of folks can be interrupted when they're not able to pull off a stable version of the pipeline, and it can require urgent corrective work in order to remedy problems later. So I believe, this is an area that does deserve careful thought, even more than the traditional DevOps literature currently, addresses. Pre-flight testing often distinguishes those organizations that have mature testing versus those that are not so mature. This is an area that I think a lot of organizations struggle with. In many organizations, the testing environment itself available for pre-flight testing is not really up to the level that the deployment environment has, which is understandable, but is a weakness in test engineering strategies. If you are testing in an environment that's not really a good facsimile of the production environment, then you're obviously going to have some potential problems when you deploy to production. So one of the best practices is to really think hard and invest in the test environment throughout the pipeline, and starting with the pre-flight testing environment to make sure that it is as complete as much as possible and is a good representation of the different system configurations, environment variables, the underlying system variables, operating systems versions, and different use cases of user workflows as much as possible, even during pre-flight and every subsequent stage in the continuous delivery pipeline. So tests should be conducted in a realistic, production equivalent test environment throughout the pipeline. in general, even pre-flight tests are done this way in best practices, mature uh, test environments. One of the key concepts behind DevOps overall, I think a lot of people may not know, but this fellow Patrick DuBois, who is a quality assurance engineer consultant, conceived DevOps, and it was really conceived as a way to tie together dev and ops and getting them to work closer together and recognize, test results, so that the test results were a binding factor, so that dev and QA and ops could, agree on how well code changes were going through the pipeline and in a consistent language. And it's interesting that testing is really at the heart of all of that. So culture uh, between dev and ops and all the different other organizations, that are affected and stakeholders associated with software development and delivery is really critical. And as I mentioned at the beginning of this talk, it's often considered the number one critical success factor, because if there isn't a general agreement between the different stakeholders that they want to work together, no amount of tooling or testing is going to make up for that, or certainly not going to get the benefits of DevOps if the cultures are, have clashes and frictions. Ironically, though, DevOps itself does not prescribe roles for individuals. Instead, it emphasizes that cross-functional teams should decide, who owns testing, for example, who's the best person in the team that should be involved in creating tests or automating tests or analyzing test results. Um, that's not a prescription of DevOps itself, but it does prescribe that somebody should be doing it. And in general, quality is, everybody's responsibility. That idea is not new. Edward Deming, Dr. Deming is famous for this quote, and his quote is long-standing, going back to the days of, the Toyota methods and so on of lean engineering. But it's true. It's as true today as it was then, and it's certainly true with DevOps and test engineering. This slide underscores some of the fundamentals of DevOps test engineering and differentiators compared to other testing methodologies. First of all, with DevOps, definitely testing is integrated into the tool chain. Everything from, development, code creation through to deployment, testing is fully integrated at every stage. I've already mentioned that. The test environment itself is orchestrated. So in a best practices environment, you don't have static test environments. You have the ability to orchestrate those environments on demand. That's one way to be able to afford production equivalent test environments, because you can stand up the environment as needed and release them and have them reused for other things efficiently when they're not needed. So that's a key point with DevOps test engineering. Thirdly, tests are automated as much as possible. Clearly, if you're going to have quick, continuous delivery incremental uh, cycles on improve lead times and frequency of release, and many of the tests cannot be done manually. There's simply not enough time. Even with many parallel people working, there wouldn't be enough time. So as much as possible, you automate the tests themselves, and that finally you accelerate those tests as much as possible as well. So even with automated testing, if they're not built properly, they could take a long time and they're not going to run fast enough. They're going to be bottlenecks in the entire, continuous delivery pipeline. So you accelerate tests as much as possible as well. So I'll be talking a little bit more about some strategies for each of these things in a few minutes. This slide outlines 5 tenets or principles of DevOps testing. At least the first 4 of them you've probably heard of frequently. They're covered quite a lot in DevOps literature. The 5th one, something I tend to emphasize, I think, more than anybody else I've seen, and I think it's just as important. So basically, the first tenet is shift left, meaning you conduct tests as much as possible, as early as possible in the pipeline. The general idea being that, if you conduct tests too late in the pipeline, then you're going to find problems late in the process, and this is going to cause churn, sort of like the waterfall problem where you have to take a fix all the way through the process in order to make it a release deliverable, and it wastes a lot of time. So not all tests can be conducted at the beginning of the pipeline, but as you'd make an assessment for each one to decide, can a test, at what point in the pipeline is the earliest point that it could be conducted. Fail early simply means that you try to order tests and test uh, themselves internally to a test script, for example, so that the most likely problems are found early rather than late in the, let's say, test suite or test itself. So, and if they are found, then you deal with that immediately and not wait until, let's say, all the tests in a test suite are run before deciding that something has failed. Failing often simply means that you do run tests frequently with different conditions, and you try to find out, with the same test, run it again and again in different environments and see whether or not the different conditions will fail. And better to find those problems during the pipeline rather than with the different conditions that a product or feature or service will experience in the field, in deployment and production. The fourth is to test fast, so you arrange the tests to run in quick, cycles, and accelerate tests as much as possible. And there are different techniques for doing that, but essentially you're trying to run each test quickly so that they don't take too long. And there are different means to break up tests to do that and make sure you get the proper verdicts in the highest priority test done early. And finally, as I mentioned, something that I really emphasize is relevance. You can run tons of tests, but which tests are the most important depending on what change is going through the pipeline. That may vary. And also, there's no point in just dumping tons of test results to everybody. Steer the test results that are most relevant to the right people at the right time is another tenet that I believe is critical for high performance DevOps environments. In this slide, I emphasize that testing itself requires an infrastructure, and a lot of folks underestimate what is needed to really get the infrastructure right. It's not just a matter of plugging in some tests into your DevOps tool chain, but testing itself has a number of steps and stages that require support. So yeah, the first step is to integrate testing into the DevOps pipeline, but do it in such a way that will support relevant as well as timely assessments for each DevOps stage. So it's not just a matter of saying, plug in testing at the CI build stage, but rather consider how testing is going to be integrated into every stage in the pipeline. And for every one of those stages, the test should be automatically triggered from the DevOps toolchain. So let's take, for example, during the test creation stage when people are coding, then you can automatically trigger, let's say, static analysis or unit tests during that stage in pre-flight, and then again during integration, and then a more complex test during acceptance testing or delivery stages, and pre-deployment tests during the delivery stage and prior to deployment, and even after deployment. You can have certain kinds of tests that are conducted automatically, and all of that can be tied into the pipeline and the tool chain. Keeping in mind again that DevOps testing itself is not what's important, it's really the results of testing. So you also have to consider how are you going to display and process results to provide feedback to the most relevant people at the relevant time to support DevOps workflow decisions. One thing I often find people get confused is, what's the difference between orchestration and automation in general, and regarding testing, environment orchestration and test automation in particular. So this slide simply explains the meaning of these things. The environment for testing, meaning all of the tools and configurations of the system under test, and the test tools have to be, stood up or set up before tests can be conducted. So automatically setting up the test environment and all the resources needed for testing, which can be both physical, virtual, even interconnections between test tools and test systems on our test need to match the requirements of the test, and the uh, activities of orchestrating involve automatically setting up the test environment and resources to conduct the test. Whereas test automation and automation in general is all about executing tasks, while test automation is executing test tasks, again, without any manual work required. I would again emphasize that it's more than just running tests logic, but also running it to the point where you can produce some verdicts automatically that can then be used for assessment. A/B testing is a technique I think that is often underutilized, but is very important for DevOps. And the idea is that some tests are hard to conduct within the DevOps pipeline itself, and need a lot of judgment by customers. So the idea is that you build the software in such a way that feature toggles or feature flags, some people call them, can selectively expose different variations of the software to different trial customers, thereby enabling some controlled evaluations of features and alternative designs within a deployed environment. And then once it's decided which variation is the best, then you can just keep the toggles on in that way. Usually these tests are conducted with full knowledge of the clients, but sometimes they aren't. But the general idea is that things like usability and other things that are sometimes hard to predict, how they're, which version is going to work best. This is a good approach. And you might even have more than two. They call it A/B, but you might even have multiple different variations that are being trialed. This is a way to, allow the changes to go forward with fairly low risk. A lot of folks are concerned that they may, make a change and it won't be the best one. Well, this is an approach that does work. It does require full cooperation and architecture and engineering and development in order to properly accomplish this. Interestingly, I find a lot of people get confused about the difference between blue-green test strategy and A/B testing because it's sort of maybe because there's two things mentioned in effect by the name, but fundamentally blue-green testing has more to do with introducing software into a deployment environment safely. It's not really about evaluating different alternative designs like A/B testing. So the general idea is that you have two production environments that can be swapped very quickly, and they're really identical. So when one is live, the other one is in test mode, and you can very quickly just swap them, usually through just pointing a load balancer or something at the other environment. And the general idea is once the new environment has been tested sufficiently, then you switch the router so all the incoming requests go to the other environment. It provides a very rapid way of rolling back as well if there are some problems occurred. So usually both environments are kept working for some time until there's confidence in the new version. Canary testing is another testing and deployment strategy, somewhat similar to blue-green and A/B testing in that context, but the key differentiator is that with canary testing, the users are unsuspecting that they're trying something that hasn't been, fully accepted as production. So canary test is pushing, a change to some number of unsuspecting users, and the goal is to, have them use the code transparently, even though it's a real environment, and it provides feedback to the development team and the company that's producing the change. It offers some limited level of production testing. It's usually in a fairly limited deployment area of their production environment, and gives early warning of possible errors that can be reverted quickly when problems occur, kind of like the canary in a coal mine. When the canary died, the coal miners knew not to proceed, and that's the idea of canary testing as well. It gives you early warning with some users, and it's an interesting test strategy. A number of companies use it, and does work. Obviously, there are certain applications where this would be kind of dangerous, but it does work in some environments. There's a genre of DevOps called DevSecOps, which really has to do with integrating security aspects into, into DevOps, into the continuous, development and delivery cycle, rather than security being some afterthought or some parallel set of activities that, have to be integrated later into DevOps. And with DevSecOps, from the get-go, security testing and security considerations are built in. So in DevSecOps, development expertise is embedded into the tests, usually in cooperation with the security experts of the organization. So the security experts become part of the DevOps team and partner with each other to train each other regarding the best practices of security and different kinds of tests throughout the pipeline. It's important to select security-ready test tools as part of the tool chain, tools that can be, coupled in a tool chain, and the results can be made visible in the infrastructure of testing and the DevOps assessments. So certainly automation is critical. Some examples are static code analysis tools that scan code for security violations during pre-flight and continuous integration builds. Penetration testing and other kinds of security testing can be built in also into integration and functional testing rather than having to be done separately. So it's especially important in environments where security is really critical and even possibly essential and required for passing audits, for example, to build it in. Otherwise, some of the benefits of accelerating code development and delivery through DevOps will be undermined by not having all the security practices keeping in pace with DevOps and DevOps testing. There's a growing trend to use microservice architectures for good reasons. Big legacy products that have a lot of complexity are, harder to test, require more test cases, and potentially can be challenging to process during rapid, development and delivery cycles like DevOps. So the idea is that with microservices, a big legacy product is broken into small, so-called independent microservices that together make up the service. There are lots of advantages of this type of architecture. From a testing point of view, all of those things do need to be tested at least at some point, and to make sure that the contracts between the different microservices of the application programming interfaces, for example, do work and are maintained. And so a regression suite, for example, for APIs is an example of what a test strategy should include. Also, dependencies that are known to exist between microservices need to be tested to make sure that the interdependent microservices are working, and any changes to one of them continues to perform in a system. Any failures that may occur in one microservice in a chain of dependencies could cause a cascade of problems at the overall service level, and that those scenarios need to be validated and with testing. Changes that affect the overall allocation of responsibilities at the architecture level between microservices are especially important to test. So all of the different microservices that are possibly affected by that change should be retested. And finally, backwards and forwards compatibility policies between microservices should be tested explicitly. One of the advantages of microservice architectures is that you could mix and match different versions of microservices in a system, and there are certain policies for every system which versions are allowed or not. That those combinations do need to be tested. The topic of containers is something that we probably could spend a lot of time on, but I'll just touch on briefly the idea of test containers. Certainly applications are more and more being packaged in containers to simplify deployment throughout the pipeline and especially into production. The immutability of containers is a very attractive concept where you test it once and repeat, and just being able to tear down an environment and replace it rather than having to reconfigure it are some of the advantages of containers in general. But when you talk about testing, where do you put the tests for a container? So in general, the best strategy is to have a container for the test environment itself. So you'd have a test container that contains the tools, images for the tools, and the test environment configuration variables, and anything required to do a test in a container. So not every single script, but one container should at least be pointed at a test um, container should be pointed at what it can test, and so you can recall the test environment as quickly as the container itself when needed. It should work in all the different environments: testing, staging, production. It can be deployed using the same mechanisms as the application microservices. This has some advantages of being able to reduce the total, footprint, size of files and dependencies between microservices, because they can be reused and instantiated or taken down quickly. And any test environment can use these containers. You can always go back in time and rerun specific versions. There's a lot of advantages. I really don't have time to go into it in this short presentation, but this is the best practice to have a separate test container to go along with application containers. One of the key tenets of DevOps testing is to test fast, and to do that requires accelerating the tests themselves. There are many techniques for doing this. Here's some examples. I mean, first of all, the team itself should be, trained on how to write fast tests and how to take advantage of the test environment that they have available to run tests quickly and the way the tests are configured and so on. So first of all, having powerful resources, which is the idea of vertical scaling. If you want to run some tests faster, sometimes just having more powerful servers or virtual machines or container environments can speed up the execution of the tests. Sometimes tests can be run in parallel to maybe have multiple tests running in parallel. So that's horizontal scaling. Being able to choose test design for fast execution. The test tools. Some tools are faster than others, so that's something to keep in mind when you're selecting test tools. That how fast can they actually operate? Organizing schedules and test suites to fail early. So if you have a series of tests or test suites, make sure that they are configured in such a way that if they fail, that you don't have to wait for all of them to complete. So that's a way of accelerating the idea of getting assessments quickly. Designing test cases to fail early. So even individual tests, the same idea applies, where you don't wait till the end of the test to fail. You stop as soon as it's clear that that test is going to fail. And then arrange the test to minimize wait times. There may be some timers, for example, within a test that are important to keep long in some longevity tests, but maybe early on in the process you can have them run with short timers. These are just some examples. Don't really have time in this talk to cover every possibility, but that gives you the idea. As I've indicated before, really testing isn't the point. It's really the results that are most important, and providing data for analysis and assessments. So the key is to think about how are you going to use test results, how are you going to package the test results, prepare them and distribute them, make sure there's clear responsibilities and service level agreements amongst folks that are preparing and processing any test results. Designing the test scripts for efficient analysis is important. Choosing tools that are designed to produce results quickly, not just to run tests quickly, but actually get to the results fast as well. Not wait till the end of a test to get those results. Configuring tools to process the results as they're available, and again, not wait till the end of a test suite to start processing results. And finally, configuring workflows for optimum analysis. So making sure that the right people get the right results quickly, rather than having some inefficient workflow. These are just examples. I find test coverage is often a controversial concept. Getting agreement between team members and stakeholders as to what constitutes sufficient test coverage is critical because, how do you know when testing is done? How do you know when a release is ready if you can't even agree on what complete coverage is? This should be something that is a fundamental agreement amongst all the DevOps stakeholders. Uh, so there are different methodologies. I'm not going to go through all of them here in this one slide. It could be a presentation by itself, but for the most part, at least keeping track of the percentage of tests that were run and the percentage of those tests that passed relative to some coverage metric is a good approach. And test plan coverage is popular to decide, what tests constitute a good release and make sure that the percent passed and run are measured and reported. One thing to be especially careful about is the selection of test tools. Not all test tools are equal. There are some tools that are more DevOps ready than others. There's a report out by IDC, is a couple of years old now, but it's still relevant. A large percentage of DevOps environments aren't working very well because they chose the wrong tools. So don't be stuck on a particular tool. Make sure that whatever tools you choose have the ability to integrate well into a tool chain, typically through RESTful APIs to configure, control, and report test results through the tool chain to be able to get that assessment data back up to the, through the test infrastructure and the decision processes that are as much as possible automated in a framework, whether it's Jenkins or something else. Being able to orchestrate in a virtual or cloud compatible environments, being able to dynamically scale and have various features for automation that will be important to really optimize testing. Test planning is a controversial concept for some reason, which I often fail to understand, but there's a lot of folks coming out of Agile thinking that think, well, with DevOps or Agile, you don't really have time for proper planning, but nothing could be further from the truth. It doesn't mean you have to write a test plan for every single change, but for goodness sake, there certainly should be an overall strategy and plan for a service or a product, and then you can iterate within that plan to write specific test cases. But in general, yeah, definitely test planning does apply to DevOps and having a strategy. And usually things like a contract for measuring test coverage is important to get clarity on in that documented strategy. And it should certainly be reviewed by the different stakeholders. This slide simply provides some high-level guidance for what kinds of tests ought to be planned for execution in the different areas of the pipeline. So pre-integration certainly should include any code logic testing. Detailed feature functionality should be tested prior to integration, and pre-flight basic performance testing of features uh, to make sure that the change is sufficient quality to be merged into the integration branch. If you do anything less than this, you're definitely opening yourself up for integration failures and pipeline interruptions. Meanwhile, at the integration stage, at least validating that changes are integrating well and doing some overall system performance testing is important. It could involve initially just a small set of, let's say build tests or smoke tests, some people call them, and it can also include some regression tests and verify at the system performance level as well to make sure things like microservices are integrating well and don't have any dependency failures when changes are made to one that blow up the others possibly. At the delivery phase, verifying that the packages and tools that will be used for deployment are working properly is important because the next phase of deployment uh, depends on it. And during deployment, A/B, canary, blue-green testing should be planned, and this needs to be planned well up front. For example, you can't really do A/B testing without way back at the development phase having feature toggles designed in. Well, this talk doesn't have time to go into details. Certainly, a lot of folks talk about test-driven design as important for DevOps. I concur with that, but often there's not enough thinking going into the regression strategy for systems and services in DevOps. So I wanted to talk briefly about that. With DevOps, certainly regression does still apply, probably more than ever, and most of the tests need to be automated. The regression test should be identified as part of test planning during the development and even pre-flight environment. Test selection itself should be dynamic, so only the tests that are relevant to changes are selected during regression testing, or else there's a possibility that the number of tests explodes too much and slows down and bottlenecks the whole pipeline. Testing reporting itself should also be dynamic, so only the results that are relevant to a particular stakeholder should be reported to that stakeholder. Otherwise, you're wasting their time and, again, potentially bottlenecking the pipeline. Newer upgraded tests should be determined for every feature found defect or test escape. They should be folded in. They're usually quite important to cover during regression. Customers will tolerate a problem with changed features sometimes, but they're not very tolerant to seeing a problem coming back again and again. So you want to make sure that those, if you like, test escapes are covered, and the regression suite is the right place to cover those things. Tests should be maintained just like code in a version management system, and any regression tests that are reporting false failures should be isolated and repaired before being used again. So these are just some of the best practices for regression testing. So there's a whole set of disciplines and methodologies around creating tests themselves. Which one is best for DevOps? It kind of varies, and there are different preferences, but overall, scripting tests from using scripting languages is popular. Something called keyword-driven tests has some advantages in that you don't have to script every step in a script. They've got some keywords that are associated with different snippets of the tests and repeatable, and isolate the code logic of the test from some of the more important aspects of it, of whatever the purpose of the test is. Interactive capture replay is very popular, has some downfalls in that, once you want to parameterize what was captured, some tools do that better than others. Test-driven development is a methodology that is certainly applicable to DevOps, and it can be applied not only at the unit test level, which it typically is, but even at the feature level, where you write a test prior to the code to make sure that you're pretty clear what the code is supposed to be doing and that the test is working. Test that hasn't been tested isn't a very good test, right? So fundamentally, this is a good way of making sure. There's a whole bunch of tools that are focused on model-based testing rather than writing individual scripts. You build a model for what's being tested, and then the scripts are generated automatically. There's pros and cons with this approach. You can get a lot of good tests that way, but sometimes they're hard to understand afterwards because they're automatically generated. Similarly, behavior-based tests, I actually have an affinity for, where the behavior of the system under test or service under test is described, and then tests are generated from that. So they all have pros and cons. I don't have time in this talk to go through all of that, all the pros and cons, but they're all relevant and they're worth studying depending on your environment. One thing I often find is not well taken care of, but is important, is to have a database for managing the metadata associated with testing. Some of the more sophisticated and mature test environments have recognized this, and they have a specific database to keep track of things like descriptions of tests, test schedules, attributes of test results, even sometimes the time it takes to execute a test, verdict history, trends, and things of that nature that can be valuable information to mine and even use in line with an automated continuous delivery pipeline. The database itself is best configured as a microservice so that the database data can be used in line with for test selection algorithms and test analysis algorithms within the pipeline. The test scripts themselves are usually not kept in this database. They're usually kept in a separate source version management system. So DevOps testing has benefits that are really consistent with the benefits of DevOps itself, and I would argue that a lot of the benefits of DevOps itself are derived from DevOps test engineering. At the business level, DevOps accomplishes reduced time to market, partly because of the cooperating tool chains and the ability to assess changes going through a pipeline quickly and shorten lead times. Similarly, it's really the well-engineered test environment and tests that improve quality. Otherwise, you can have faster changes going through a shorter lead time pipeline, and that could blow up quality. But what keeps it in check is proper DevOps test engineering. Meanwhile, you can't just have, an infinite amount of test resources. You need to have smart orchestration and test automation to help reduce costs while at the same time improving quality and reducing lead times. Innovation is actually improved. Why? Because if things are engineered properly, then people are given back time to do things in a more sophisticated way, whether that's the product, the service, or the infrastructure itself. So everybody has a chance to innovate more. And finally, the teams generally are more happy because they realize they're working with a more sophisticated, modern, environment in which they're able to grow and benefit from that. So the team, is more proud of their work with pride of ownership, and the results are something they can be proud of. Overall, it gives them a chance to get more timely recognition. Lots of benefits, and these are all very real if the test environment is engineered correctly. Well, the flip side of not doing test engineering properly are pretty severe compared to the benefits. So if you try to implement DevOps test engineering without really addressing the need for culture and collaboration, you can have a lot of friction. Like let's say, for example, QA and Dev don't agree on who's supposed to produce the tests or analyze the results. And you start doing a lot of tests quicker that'll only exacerbate or accelerate friction. So it's important to get cultural aspects and role responsibilities sorted out as part of that. Dealing with test escapes, you can have more test escapes and a lot of false positives if tests aren't engineering properly, or if features are released without proper, testing. Also, false negative results if tests are too forgiving, then you're going to have problems deployed to the field more quickly with DevOps. And finally, competition is going to be severely beating you up if you don't have, good quality products being produced through a fast DevOps pipeline. Customers these days are not very forgiving. In this world of social media, it's pretty easy for, bad results to be advertised very quickly. It only takes a few customers complaining. So these are consequences of not doing DevOps testing properly, and certainly, underestimating or under-resourcing testing while implementing DevOps is generally, not a great idea. So to get the benefits we talked about, be aware that, there are consequences if you don't do testing properly and yet you go ahead with the DevOps program. To learn more about DevOps test engineering, there is a course available through the DevOps Institute that's called DevOps Test Engineer. It is a certificate course, and it covers in detail the purpose, benefits, concepts, vocabulary of DevOps testing. It goes into much detail regarding how DevOps testing differs from other kinds of testing. It covers testing strategies, test management, results analysis strategies, how to select test tools, and how to implement test automation and frameworks. It covers the integration of DevOps testing into continuous integration and continuous delivery workflows. It talks about how DevOps testers fit within a DevOps culture, organization, and roles. Overall, it goes into some detail regarding best practices and provides some checklists and tools that are valuable for anyone really serious about trying to understand DevOps test engineering, and in particular would like to get a certification recognition for learning that and demonstrating their knowledge of these things. And you can become a certified DevOps test engineer through this program. If you want to learn more, the link at the bottom is something that you can take advantage of. Finally, I'd like to thank you for paying attention to my talk. And again, I encourage you, if you have questions for me personally, to connect through LinkedIn at the link on this slide, or look me up through just searching for DevOps the Gray. You can also look for my articles on devops.com. I also publish slides on SlideShare and sometimes talks on YouTube. So anyways, thank you for listening to my talk, and I hope to connect with you again soon. Thank you.